All right, here we go. Block with 4 forces. The free body diagram shown above is for a 5 kilogram box on a rough surface being pulled to the right at a constant speed, so forces balance, no acceleration, by a string that has an angle of 30 degrees above the horizontal. The coefficient of kinetic friction between the box and the surface is 0.30. Don't forget, kinetic friction happens when objects are sliding against each other. So we're looking for the value of the tension in the string. All right, so let's make some notes. We have no acceleration because we're moving at a constant speed. So acceleration is 0. Coefficient of friction, kinetic friction is 0.30. We know the mass of the box is 5 kilograms. We know it's a rough surface. We already said that because we have friction. So we're looking for the tension in the string. We're looking for tension in the string. All right, well, tension is at an angle. So we're going to have to resolve it into components. Here we go. I'm going to redraw the free body diagram. mg. Notice I'm drawing Fn small, normal force, because it's getting some help from tension, right? It's getting some help from the tension force. There's a component, right? There's a component of tension that's vertical, and there's a component of tension that's horizontal. All right, and we know that angle is, I believe it was 30 degrees. Okay, this component over here will be t times sine 30 because it's opposite the angle, and this will be t cosine 30. And then finally we have friction, and the friction force should be exactly the same length as the component of tension in the x direction because it balances with the friction force. So we'll draw it approximately correct. Okay, and now let's go ahead and write two equations. We'll write sum of the forces, that was a little sloppy, sum of the forces in the x direction equals max, and then we'll write sum of the forces in the y direction equals may. Now this object is not accelerating horizontally and it's not accelerating vertically, so really the sum of the forces in each direction is 0. Don't forget this is y and this is x for the sake of this problem. So what are my x direction forces? Well, we have t cosine 30 in the positive x direction, and we have ff in the negative x direction. Okay, so that's in the x direction. In the y direction, we have Fn plus t sine 30 minus mg equals 0. Okay, so we know another thing. We know the friction force is equal to mu k times Fn. The equation on the left, let's rearrange. T cosine 30 equals ff. Then we'll divide each side by cosine 30, get t equals ff divided by cosine 30. And we can replace ff with mu sub k Fn. Okay, so notice I had ff and I replaced it with the equation for ff because ff is equal to mu sub k Fn. So I've derived an expression for t. I can plug this expression for t into t. Let's try that. Substitution, so we have Fn plus, and now instead of t, I'm going to write mu sub k Fn divided by cos 30 minus mg equals 0. So I just replaced t. Oh, I forgot the times sine 30. Okay. Now mu k Fn divided by cos 30 times sine 30, all of this I can rearrange because this is a number, 0.3, this is a number, and this is a number. Okay? And m and g I know. So I can solve for Fn. Okay? So let's grab our calculators. And 0.3. Well, I'll show my substitution. I'm going to rearrange this as Fn plus Fn multiplied by mu sub k times sine 30 divided by cosine 30 minus mg equals 0. So I just rearranged this portion right here. I pulled the Fn in front because I'm going to end up combining it with this Fn. And now I'm going to do 0.3 times sine 30 divided by cosine 30. Times Fn plus Fn minus mg equals 0. Here we go, 0.3 times 30 sine divided by 30 cosine equals 0.173. So I get Fn plus 0.173 Fn, and I'm going to move mg to the other side. So the mass was 5 kilograms. I'll use 10 kilograms times 10 newtons per kilogram. Now let's go. So 1.173 Fn equals 50 newtons. Divide each side by 1.173, and you get Fn equals 42.62 newtons. So I'll go back to my drawing up here, 42.62 newtons. So just figured out Fn. Well, I said this was 50 newtons because it's 5 kilograms times 10 newtons per kilogram. That means T sine 30, this value must be enough to make up for, right, this value has to be 50 minus 42.62, which equals 7.38. 7.38 newtons. Well, if I know T sine, well, I can go back over here to my equation now. Actually, let's just use that, what we just figured out. We just figured out T sine 30 is 7.38 newtons. Well, if that's true, if T sine 30 is equal to 7.38 newtons, then T is equal to 7.38 newtons divided by sine 30. 7.38 newtons divided by sine 30, which is going to give me 14.76 newtons. And I believe the answer closest to that was answer A, which is 14.47 newtons. So notice I'm a little off because I didn't use 9.8, but I'm close enough to eliminate all the other choices.